and you could either have something running away from that target or trying to capture that target that moves. Does that make sense? Okay, so you can start to implement those.
Are those just the same as seek and flee, but with a moving target?
Yes. Yes. It says, hey, here is your script. Let's not make it a vector 3, but let's make it some object that's moving around the screen. Okay, so let's save this. Seek and flee. This was called the seek script. It's actually the flee script right now. So let's change that back. And I would recommend, as we do this, writing a separate script for each steering behavior. Because then, these components can be combined. We've only really attached one script to each object, but you can have an object that has 6 scripts on it that are all calling their update method sequentially. As that object, it says, hey, update. Every component inside me, update. So some of them could be adding a force to go this way. Some of them could be adding a force to go that way. And you're starting to combine those steering behaviors together to really start to make interesting things happen. So when you include lots of these agents wandering around, they have a behavior that you can program to say, like, go find yourself up there. There's also a behavior that you can say, avoid walls, and then there's a steering behavior that says, avoid other people. And when you put them together, now all 3 of those steering behaviors are not just having one force being applied to where you are, but 2, 3, or 4 forces pulling you in slightly different directions, navigating you to where you need to go. Okay, so that is basically our next task. I've demonstrated a simple steering behavior. I want you to be implementing multiple steering behaviors in a flocking kind of idea. Let's look at that. Oh. Silly. That's why I had the Java security up. Yes. Java control panel, security, edit site list. Yes, Java, I know what I'm doing. Please let me go. But now I have to quit Chrome and start it up again. Hopefully I don't lose my 7 windows of all my Unity references. Probably will. Yep, they're gone.
Control Z. Yeah, Command Shift T.
Command Shift T. Oh, perfect. Wow. I love you guys. This is great. So, yes. Here we go. Now we're doing flocking. They're moving around in 3D space using 3 different steering behaviors. A separation steering behavior, an alignment steering behavior, and a cohesion steering behavior.
I'm assuming each one of these behaviors gets a certain weight in terms of how much the object listens to that particular behavior.
Yes, exactly. And that is something you could do in the scripts. The different speeds that I attached to that simple script here, that could be your weight. What is your weight you're attaching to this script? What is the weight you're applying to the separation? Okay, to do that, you need to not just know there's one target out there, but especially for these, you need to know who's around you, what's going on in the local area. So I'm glad I got all these tabs back. Now, there's rigid body velocity, vector 3 normalized, transform forward, add force, debug log. Oh, I didn't have it up. Okay, so we need to know about two things. Ray casting. Let's go back to C#. Ray casting lets you say, I'm an object, and just like anywhere I want to have a point and a direction and a distance of some light ray that I'm going to shoot off. Now, hopefully, this ray is going to hit something. When it does, it returns true. So, if you are an object and you're wandering around, you can say, is there anything 10 meters in front of me? Where you are, you have a direction, and you say 10 meters for your distance, and this will shoot off a little ray, and if it detects something in that distance, it'll say true. But you could also ask it, what is the thing that I hit? It gives you back a true, and it has this parameter raycast hit that you give a reference, and when it does hit something, it fills that object in and lets you look at it. So a raycast hit talks about the collider that was hit. Talks about how the distance of how far it was to get to it, the point of where it was, the rigid body of the collider, the texture, transform, other stuff like that is just readily available to you. So you could say, not just that I hit this thing, or not just that I hit something, but I hit this thing. So raycasting lets you do that from anywhere you want. Here's my object. You can even pick an origin that's somewhere else, shoot a ray, and now detect what is in your local environment. So that's a really cool thing for these objects to do with ray hit. Other things that we need to know about is overlap sphere. Especially for these behaviors, you need to say, what's going on in my 5-meter radius? Who's out there? Not just, I'm looking in this direction, will I hit anybody if I keep going? That's an important factor. If you're trying to do, say, like avoidance, obstacle avoidance, this is when you want to do that ray hit. This is where I'm going. Am I going to hit anything? If so, let's change my vector to avoid them. So ray hit is good for this kind of steering behavior, but for these, we need to know who else is around me and adjust my vectors based on averaging them all together. So overlap sphere gives us that ability to return to us a collider array. Tell me everybody in this sphere, starting at this position, telling me the radius, and giving me a layer mask of who I want to look at. So if I'm running around the world, I don't have to say, hey, there's a bunch of walls around me. I can put those in a certain layer, like we saw, and I can have the bots in a different layer and just try to say what things are out there in a 5-meter radius that are other bots that I need to worry about. Does that make sense? Layers are important. Does everybody understand what a layer mask is and how that's different from a layer? Does anybody? What is a mask?
A mask in general is just something that specifies either, like the bit mask is like it looks for specific bits, and if you have all ones, then that means you care about everything in each of those positions. But a mask could be just be a subset of those. So like with layers, it's do you want all of the layers, or do you want a specific set of layers, or do you want just one layer?
Yes. So you can think about it in terms of files. You're all familiar with files in a file system, hopefully. Those files can be read, write, or execute. for certain types of users. The way those are built up is in terms of masks. They each get a bit, read, write, or execute, and that gives you 3 bits to work with, which means there's 8 possible ways to combine them. And what you can do and what the computer does is just use a number to say, do you want read, execute, or do you want read, write, execute, or do you want read, write, privileges? How do you want to combine them is just in terms of one number. So that's what a mask is going to be. You can specify one layer by itself, or you can best specify a bunch of different layers, and it usually involves bitwise operations with the ands and the ors and other things coming in there together. So those are the pieces that you will need to investigate overlap sphere and raycast to start implementing these steering behaviors. So there's a long list of them here. Obstacle avoidance, wall following, all based on a simple target or raycast. What should I do? How do I figure out a vector to apply to myself? And then how do I apply a lot of them at the same time? Any questions? Okay, so this is the scene I made just to test this stuff out. So I threw together, let's bring it back. I put in the third person character, and I was like, okay, everybody's going to seek this guy as he runs around the screen. They're not very fast right now, but they are trying to seek him. And you can see it really if you turn around and start running. Oh my God. They're all there. Yeah, exactly. Yep. And so they're all coming for him. So you can make a little game where things are trying to get you and turn you into a blob. And yeah, if I turn around, like, ah!
It is the blob.
Yes. So here's one thing I can do. I can jump on top of them. And now, oh, it fell through.
But they were going up.
They were going up. I got this to work before where it took me like 50 feet in the air.
You just like continually walk on them.
Yes. Flip myself around. Up, up, up.
Oh. They like suffocate you.
Oh, and they suffocated.
This is how you die.
Yes. Get out of there.
You're so close.
So close. Get out. Get out.
They keep seeking.
Yes. Yes. I got out. But what I really want to do is jump on top of them all. So you can see. There we go. Oh, and I fell through again. Okay. But I had gotten it to work where it just started levitating up in the air because they were all seeking me in that third dimension. Okay, questions? Questions about what we learned today? Triggers. Invisible boxes that can make things happen in your game.
Dailies.
I call them dailies. Yes, because they just try to exterminate me. So, we learned about collisions. When you hit things, you can react to them by writing a piece of code. We can destroy things, and we can steer things with adding forces. And thinking and probably learning more about physics than I know will be really helpful for you as you try to implement these steering behaviors. So I'll come up with an actual assignment and send that out about these steering behaviors. But the general gist of it, I want you to take what I did and implement a couple of these steering behaviors and implement a flocking voids implementation. It doesn't have to be in 3D. It's easier to do it in 2D, but you can get it to work in 3D. Now you notice when things disappear on the right-hand side, they show up on the left. On the top, they show up on the bottom. So you'll probably want to start thinking about your space as a torus.